Okay, everybody, as promised, I have your study guide for your final. These are the things that I have to report to Hack. So I don't need to read every single thing to you. Okay. So the first thing that we're going to do is this exponential function. So as you can see, the learning outcome is exponential and logarithmic models. And you're going to use Cami to fill this out. If you've never used Cami before, you can watch a little YouTube video on. Okay. So with this exponential model, we're solving for the letter T. So you have to remember back of how you solve for the letter T. First up, with this exponential model, you'll always see the formula A equals A sub 0 e to the RT. Okay. And then you're going to divide both sides by the number, whatever number it is, A sub 0 to isolate the exponential. And then in the step 2, you're going to take the natural log of both sides. So you're going to have A divided by A sub 0 equals e to the RT. And then in step 2, you're going to have to take the ln of both sides so that the e goes away, right? But, with the power property, you're going to bring the RT in front of that, and then you do the ln of e. And then you're just going to divide everything by r, okay? So the initial population, you're going to be given a number, right? So the initial population occurs when t is equal to 0. Okay. So the initial population occurs when t is equal to 0. So p of 0 equals, so the e to the, the RT, right? So the r is times 0 because it's times t. So the population, is it increasing or decreasing? And the population is actually decreasing. So the p of 0 is just going to be the number that's in front of, right? So the 52.8 here. So when you plug in the 0 here, start over from step 3. So for step 3, you're going to solve for t, and then the population model is already given to you. So p of t equals 52.8 e to the negative 0.0031 t. You plug in the initial population when t is equal to 0. So p of 0 is equal to 52.8 million. Okay? Then, is it increasing or decreasing? So if you look at the exponent, you have a negative value, right? So the r is negative. So since it's negative, the population is decreasing. So you just explain that. And then solve for time. Solve for the time when the population is 45 million. So all you're going to do is you're going to plug in 45 for A. So you see over here where we have A right there. You're going to plug in 45, and then you're going to solve using the ln of both sides, okay? So when does it reach 45 million? You set it up, and then you follow the steps. So you have 45 equals 45 equals 52.8 e to the negative 0.0031 t. And then you're going to divide both sides by 52.8, and then you take the ln of both sides. And so you end up with about, so when you solve for time, you should just show your work below. Okay. So you just write it in. Since you're using Cami, you can write it on the side. I think you can write with your finger. And it's just 3 little short steps. So you have 45 divided by 52.8, which is approximately equal to 0.8523. And the ln of 0.8523 is approximately equal to negative 0.1598. And then t is going to be equal to what you get on the other side, which is t is equal to negative 0.1598 divided by the negative 0.0031, which is approximately equal to 51.55 years, which is approximately equal to 51 years. Okay. Notice the negative signs cancel. Always double check the calculator entries for ln. Make sure you use the ln. All right, so the learning outcome for number 2, polynomial equation, f of x is equal to 2x to the third power minus 11x squared plus 24x minus 18. So what we're looking for is the end behavior for the leading term, 2x to the third power. So the leading term, 2x to the third power, is an odd degree, and it has a positive coefficient. So the odd degree, positive as x approaches negative infinity, and there's rules, they're in your book, okay? So as x approaches negative infinity, and if you get confused, just look it up in your book, f of x approaches negative infinity. And then as x approaches infinity, f of x approaches infinity. So what does that look like? So if you actually take this and plug it in to Desmos or a graphing utility, let's see. Okay, it actually worked for once. F of x being equal to. So if I zoom out, so the first one was as x approaches negative infinity, right? So as x approaches negative infinity, we're talking about going in this direction, right? So as x approaches negative infinity, that means we're going to the left side, right? That means that f of x, which is the y value, approaches negative infinity. And then on this side, as x approaches positive infinity, which is this side, f of x approaches positive infinity as well. Now remember that this is the parent function, f of x equals x to the third power. So there's rules, right? And it follows that. Now there is a positive coefficient in front of it, right? So you have to consider that too. So if I put a 2 there, right? But if I put a negative 2 there, it's actually going to flip it. So it would change it. So you have to be careful about that, okay? But I'm just modeling just the 2x to the third part, and you can see here that this is a little bit more defined. But again, if I'm moving to negative infinity, then the y value is moving to negative infinity. And if I'm moving to positive infinity for the x value, then the y value is approaching positive infinity as well. Okay? So back to the guided notes. We got that part. So possible rational zeros using the rational root theorem. So on page 398, here's the rational zero theorem or the rational root theorem, and that is what you have to do, okay? So whatever polynomial you're given, oh my God. So whatever polynomial so whatever polynomial that you are given, you are going to list the last number. Well, it's the constant term, right? So the constant term, you're going to list all of the factors of the constant and of the leading coefficient. Okay? And then, and you might want to write some more of this down in your notes from the book if you want to. It'll just help you along with studying. So you're going to take all of the factors of the constant term and you're going to divide them by the leading coefficient term, okay? So in your example, yours is negative 18, and then it's going to be over all of the terms, all of the factors of the leading coefficient, which yours is 2, right? Yes. Okay. So you're just going to do each one, and then you're going to end up with whatever you have, and it's plus or minus. You have to consider both of them. Okay. So for this one, it's -2 and 15. So the factors of -2 is ±1 and ±2. And then 15, you got to do all the factors of that. And then you have to do each one individually. So of course, if you do ±1 over ±1, you're going to get ±1. And then you do ±1 over 3, which is here. Okay. Sometimes it's just because of the order. Sometimes because of the order, you get a little confused. But if you just do them one at a time, it's, kind of the way that they have it listed here. So ±1 over the first one, ±1 over the second one. And that's where the ±1/3 comes from. And the ±1 over the 5, ±5. And the ±1 over 15. You can see they kind of skip, but just do the 2 next. So ±2 over ±1 is ±2. Then ±2 over ±3, ±2/3, and so on. Okay? So you have to list all of those. That's part B of the question. Okay? So for yours, let me go back to it. Then you're going to show that a particular zero. So it says here, the question is actually going to ask you to show that one of the zeros is a zero of f of x. Okay, so what you do there is you're actually going to plug in whatever they tell you to plug in, and then you're just going to evaluate it. Okay, you also can use synthetic division, but that can be, okay, no, you have to use synthetic division. So when you're asked in part C to show that this particular zero is, showing that this particular fraction, because they're going to pick the one that's difficult, which is a fraction, and they're going to ask you to use synthetic division. Okay, you will have a calculator, so if you get a little caught up on the synthetic division, that can help you. You can also check your answer using the quadratic formula. So I'll give you a hint that you will get some imaginary factors. Okay? All right, so but the key takeaway after finding one rational zero factor or use the quadratic formula to find all of the rest of the zeros, and you're probably going to have to use the quadratic formula. We had a homework question just like that, so yeah, you got to remember that. All right. So piecewise functions, okay? So f of x equals x squared if x is less than or equal to 2, and f of x is equal to 3x minus 6 as long as x is greater than 2, okay? You can use Desmos to help you along with this too. I'm just trying to memorize that really quick. Let's see. X squared minus 4. And actually, you know what? It might let me copy. I think, is it a comma? No. I think it's braces. There it is. And then the other one was of course, it just had to be goofy. All right. So this is what it looks like. Okay. So the way that you read this is, I'm going to turn this one off. That the function exists only up to this number. Okay. Now remember that it's less than or equal to. So it includes the number 2. But this one does not, okay? So I'm going to turn this one off, and I'm going to turn this one on. So the function is 3x minus 6, which is a straight line, right? Only from 2 and out, okay? 2 and above. So it says x is greater than 2, okay? And then the other function only exists if x, I may have said greater before, but it's less than or equal to 2, okay? So what you have to find is the first, it says use the following piecewise function to answer. The first rule defines a parabola with a vertex. So the first part is asking, I'm trying to find it. It says piecewise functions analyze each one separately. Okay, so the first one, where is the vertex? The vertex is down here. Okay, it's the lowest or the highest point of the parabola. And then, so you have to just put in the vertex. And then the second rule defines a line with a slope of, so you have to state the slope. What's the slope? It's the number in front of x. And what else and a y-intercept. So there is no y-intercept, right? Slope is 3, y-intercept would be 0, -6 if extended, but the piece starts at x equals 2. So there is no, wait, why is it saying there's a y-intercept? Answer m is equal to 2, y-intercept is, okay, so you do actually write the y-intercept, even though it's not shown on the graph. So the y-intercept for here would be 6, okay? So you can actually fill that in here. So the vertex, the slope, and the y-intercept. And then state the range in the interval notation. So the range would be the lowest point on the parabola, which is -4. The line starts at f of 2 from the parabola at x equals 2. The line actually starts just above that and goes to infinity. So the overall range is from -4 to infinity. So you use a bracket. I think I can actually put that in here. So -4, comma, to infinity, and just use the infinity symbol. So I'll just write the word infinity, and then like that. But you can just put the symbol in there, infinity. Okay. And then you just choose the correct graph. Okay. Just be careful, because when I actually give this to you, the graph might be a little bit misleading. So just be really careful about the graph that you choose. Just make sure that your graph looks like this. And it might actually have a little crosshair there. So just be careful with that. And then determine the range of the piecewise function. So the range is going to be from this bottom part, which is -4 to infinity. Okay, so it's going up forever to infinity. But you'll have a section where you just pick, it's part C. So you just choose the correct graph of the piecewise function. Okay, and then the last part, which is the difference quotient. This part I will definitely do by hand on my iPad, and then I'm going to attach that to this. Right, so you are first going to find the inverse. For learning outcome number 4, you're going to use these function operations. You're going to find the inverse of this function. And I'll do that by hand next. I'm not even going to try to explain it on the screen. And then you're going to find the domain of the inverse And then your question number 2 is going to be the difference quotient. Sorry, I missed highlighting or making that bold. So I'll do the difference quotient by hand as well. Okay. And then just make sure that you do this checklist. Check it off for yourself. Almost every single one of these you can look up on YouTube or you can search for in your book. Every single thing that we're doing here, we did in this course. So that's good that I made sure that you hit all of those markers. And I'm going to do that last part by hand. And yeah, so. Okay, as promised, I am going to do the learning outcome number 4 by hand. So I'm going to show you, and you can just figure out how to write this using Cami. Okay, so what you're going to do is you're going to write y equals the square root of 3x minus 9. Now, your problem is going to be different, okay? And then they also give you the domain here. So you're just going to swap x and y. So you're going to say x is equal to the square root of 3y minus 9. And then you're going to solve for y. So the way that you get rid of the square root is you take both sides to the second power. So you get x squared equals 3y minus 9. Then you have x squared plus 9, and then that's equal to 3y, and then you divide both sides by 3. So y is equal to, well, let me write it up here. It's actually, remember, this is the inverse. So f of x inverse is equal to x squared plus 9 all over 3. Okay? And then when you're trying to find the domain of the inverse, right? So if it helps you at all, I'm just going to do the domain using Desmos. So if I actually graph that, and I'm actually going to do f of x and that's equal to, in parentheses, x squared plus 9, and then you divide that by 3. This is what it looks like, right? So, okay, the explanation that I'm given in this sample problem is really murky. So for the domain of the inverse, just put 0 to infinity. I'm just not overly concerned with it, and I need to move on. So now for the difference quotient, right? We have the difference quotient is I'm going to write it over here. F of x plus h minus f of x all over h. Okay, so just keep that in mind. So first you're going to do f of x plus h, right? So whatever problem that you're given, wherever you see x, you're going to put x plus h. So x plus h squared minus 4 times x plus h plus 1. So this is going to be x squared plus 2xh plus h squared minus, I'm going to run out of room, minus f of x minus fh plus 1. Can I simplify anything? No, it's okay. We will be able to. So now you're going to take the original function and plug it into here. So you're going to have, I'm going to do x squared plus 2xh plus h squared minus 4x minus 4h plus 1 and subtract. I'm just going to change all of the signs already. So minus x squared plus 4x minus 1. So then what happens is that cancels with that. That cancels with that. And that cancels with that. So we end up with this 2xh plus h squared minus 4h all over h. And then we just divide. So our result for this would be 2x plus h minus 4. Okay? And that is it. All right? So, some little spots of this video may have been a little bit rough, because I wanted to make sure I got it done. So thank you for watching. And as always, give me the thumbs up. And you can always give me comments if you didn't like it. I don't mind. But I did my best for your review. Thank you for watching. See you next time.